Good morning and welcome to Exploiting CORS Misconfigurations for Bitcoins and Bounties. Have you ever looked at a Bitcoin exchange and wondered how hard that will be to hack? Perhaps you read about the recent theft of over $60 million worth of Bitcoins from Bitfinex and thought, I wonder if I could have done that. Maybe you even took a look at a Bitcoin exchange and you saw a horrific mess of WebSockets locked down with fancy HTML5 technology and sub-resource integrity, content security policy, and cross-origin resource sharing. And you thought, that looks like quite a lot of work. In this session, I'm going to share with you how CORS's simplicity is its weakness, how that weakness leads to some really interesting problems, and how to exploit those problems to steal Bitcoins. Around 7 years ago, I just got into security and I just read about these awesome things called buffer overflows. So on this particular evening, I was trying to use Firefox to trigger a buffer overflow in an FTP server by typing really long things into the URL bar. And during this process, Firefox crashed. So I thought, great, I've got a buffer overflow in Firefox. I'm going to build an exploit and be rich, right? So I asked on IRC what I should do with this Firefox remote code execution vulnerability that I was shortly going to have. And they told me about this company, and I can't tell you the real name of the company, but let's say they're called We Buy O'Day. And the way the site works is they have a website and researchers can sign up and send them an exploit for a vulnerability in a popular piece of software like Firefox, and they will take a look at the exploit, and if they like it, they'll make you an offer to buy the intellectual property from you. And if you accept that offer, then they own the intellectual property, and if you don't, then they act as though they had never seen that exploit. So it's a system that works on trust. It's absolutely imperative to the company that people trust them not to exploit people. So I signed up to this website and I couldn't get a working exploit, but I submitted my crash dump anyway. And while doing this, I noticed that this website didn't seem to be using any cross-site request forgery tokens anywhere. And it quickly became apparent that I could use that to change anybody's email address and then do a password reset to gain full control over their account. So I thought, okay, what should I do with this vulnerability? I know, I'll sell it to these guys. So I walked up and I went, hey, I found a vulnerability, it's quite serious. It isn't in a piece of widely used software, but it is in your own website. You've got a choice. You can either pay me to buy this vulnerability, or you can act like you've never seen it. And then, you know, well, fairly unsurprisingly, they bought it from me, and I was very happy with that at the time, and I didn't really think anything more of it. But looking back on it now, I have to wonder how you have a website owned by a security company with an internal team of security experts, where all of the users are also security experts. The website is full of really easily sold intellectual property, juicy O'Days in all sorts of web browsers and databases, and yet they've got a trivial cross-site request forgery vulnerability, just staring everyone in the face, and nobody notices it. I think the only answer to that is that back in 2009, awareness of cross-site request forgery was pretty poor. So you could have flaws that were really easy to exploit, but nobody was really looking for them. And what I'm going to show you is that is where cross-origin resource sharing is today. So first, I'll talk about the absolute fundamentals of CORS, purely from a hacker's point of view. I'm not going to waste time telling you how to use it. This is just about how to exploit it. And then during that, I'll mention various limitations in the CORS specification and make a case that those limitations have various unpleasant consequences for quite a few websites, including several Bitcoin exchanges. And then I'll talk about how developers, browsers, pen testers, and even specification authors can try to mitigate these issues, and take 5 to 10 minutes of questions. So, who here is already familiar with the basics of how CORS works? Okay, not a bad number of you. Cool. I'll keep this pretty brief. If you're not familiar with CORS, you really want to pay attention to this because everything else is built on this. So, say that you're Gmail and you want to let users embed files from Dropbox.com. You can easily, via their web browser, issue a request to Dropbox, but the browser implements the same origin policy, which will prevent you from reading the response. And that's the integral part of all web security. And if you're Dropbox and you want to allow Gmail to read files from your site, you can use cross-origin resource sharing, or CORS, to selectively relax the same origin policy. You do this by specifying a HTTP header saying allow this origin, and the browser will see that and will then allow Gmail to read that response. When used on its own, this header only lets the browser read unauthenticated content, so that would be effectively only public files from Dropbox. If you want to allow users to attach private Dropbox files, you would need to put the allow credentials true header on there as well. And by itself, that's pretty simple, right? For a long time, I thought that was all there was to CORS, and I couldn't really see how things could go particularly terribly wrong. Because unless you do something like typo mail.google.com, or unless someone finds a way to hack google.com, there's nothing that bad going on here. The key thing to note is that this has established a trust relationship. If someone does gain access, does gain control over Gmail, they can now read all users' private Dropbox files. What if, for some reason, Dropbox decides that Yahoo Mail is also a highly secure mail provider, and they should support them as well? Well, if you look at the specification, you might think that you can specify a list of origins. But in practice, no browsers support that. It simply won't work. So what do you do if you're Dropbox and you want to support both Gmail and Yahoo Mail? Hold that thought. What if you're a completely different company and you want to allow cross-origin access from all of your subdomains? The CORS specification does have a wildcard, but it can't be used as part of a string. It can only be used on its own. So you can say, I want to trust all origins, but you can't say, I want to trust all subdomains. And there's another catch, which is that the wildcard can't be used in conjunction with the allow credentials header that I mentioned earlier. This is for a pretty good reason. If you just pay attention when you're browsing the site, you'll quickly find random websites like developers.mozilla.org that say, we trust all websites with all of our users' private details. Why this happens, people, who knows? But it does, and browsers have decided that no one is intentionally doing this, and therefore, when this happens, they ignore the access control allow credentials header. So, what do you do if you want to support two origins or all subdomains? There's only one solution, and making it flash is the only way I can show you how bad this is. You need to look at the origin that the browser is coming from and use some code to dynamically decide on the spot whether you trust that origin. So you've gone from having a statically coded value to having some kind of logic that decides which origins are trustworthy and which ones aren't. So this introduces a whole load of new mistakes that you could potentially make. Additionally, these mistakes are much less likely to be discovered during a security audit, because if CORS headers are being, on the response, are being dynamically generated like this, typically if someone approaches from and doesn't specify a valid origin, they won't see any CORS headers coming back. So the pen tester may never realize that the application even supports CORS, and they'll never get a chance to audit your functionality that decides which origins are trustworthy and which ones aren't. So, as a direct result of these limitations in CORS, we've got security critical functionality that pen testers may well not notice that's based on parsing user supplied URLs. Now, I'm going to take a look at what goes wrong. All of the examples that I'm using from this point onwards are real websites that have bug bounty programs. So you can be reasonably sure that all of these sites have been fairly heavily tested by quite a few other people, and yet nobody has noticed these CORS misconfigurations. Also, I found all these vulnerabilities using purely automated scanning. I was too lazy to actually register accounts on any of these websites. So these are absolutely low-hanging fruit vulnerabilities. These are things that are really easy to find if you look for them. So, what goes wrong when people dynamically generate these headers? Well, the most basic error they can make is simply saying, we trust all origins. So whatever origin you say you come from, they go, yep, that sounds trustworthy. And I quickly found a fairly major Bitcoin exchange, which they sadly don't want me to tell you their real name, that was doing that. So if you came to their, so if a user visited my website, Labs Albino Wax, I could trigger a request to this Bitcoin exchange saying, hi, I'm Labs Albino Wax. Can I have this user's private API key, please? And the Bitcoin exchange would go, yeah, sure, Labs Albino Wax, highly trustworthy, and give me their private API key. So logging a user's private API key took a tiny few lines of JavaScript. This is a really simple attack. And having got someone's API key, I can, at my leisure, do quite a few things. Probably the best first step would be to disable email notifications. Because this website is a Bitcoin exchange, and historically certain Bitcoin exchanges have been horribly hacked, they're keen to show that they take security very seriously. And one way that they do that is that they will send you an email notification whenever someone logs in, whenever someone takes any action within the account or changes any sessions, or changes any settings. But that's okay, because we can use the API key to disable notifications. What next? Well, I think what I do is enable two-factor authentication. Security experts will tell you enabling two-factor authentication will improve your security. Well, what we're doing here is we're enabling two-factor authentication for someone else's account tied to my phone. So they just can't log in to their own account. That's quite handy when it comes to the next step, which is transferring all of their Bitcoins to an address of my choice. That's the simplest exploit. Since this is a Bitcoin exchange, there's actually an alternative approach that you could take, where if you've got a bunch of users' API keys, then you could potentially manipulate the market. So you could use loads of users' Bitcoins to pump a particular altcoin and kind of indirectly generate money for yourself, and thus avoid an audit trail pointing straight to you. When I reported this issue, they fixed it within 20 minutes, which is the fastest that I've ever seen a vulnerability patched in a live system. Thank you. They also told me the root cause of this issue was just a package they'd installed, a third-party package. So what that means is these guys never intended to use CORS at any point. They had no idea CORS was it was enabled in any kind of way. It was just this package happened to have some default settings that completely destroyed the security of their site. Okay, what else goes wrong? Well, I found a completely different, unrelated Bitcoin exchange, and they do some basic steps to decide what origins are trustworthy. Once again, I can't name them, but let's say they're called btc.net. They validate that the origin starts with btc.net. So if you approach them from evil.net, they won't send any CORS headers back to you. But of course, you can come from btc.net.evil.net, and they go, yeah, that sounds trustworthy. Great. So at this point, I was like, this will go into my talk brilliantly. I'll just build an exploit and find a different way of stealing some Bitcoins. And I ran into some difficulties with their API and thought, okay, I'll just come back to this in a couple of weeks and have another go at figuring out how to steal Bitcoins with this. Which turned out to be quite a big mistake. Because when I came back in 2 weeks' time, I found that the website had completely shut down. It just suspended all operations. So the website basically wasn't functional. I can't really speculate as to why that happened, but ultimately, that's why there's no exploit for that. So I'll try and be faster next time. What else goes wrong? Well, I found a different website for posting reviews of things, less exciting than Bitcoins, and they verify that the origin ends with advisor.com. So if you're not advisor.com, they think that's trustworthy. Cool. Probably the most noteworthy thing here is the number of security headers that this site used. They had content security policy, strict transport security, X content type options, X XSS protection, X-frame options. They had every security header imaginable, and yet with a couple of extra headers, they removed all their security. CORS is really quite dangerous. Okay, so far I've talked about some kind of fairly obvious ways to screw up your CORS. Now I'm going to move on to some a bit more interesting things that I would think the vast majority of you have probably never heard of. If you were paying attention earlier, you would have noticed that the specification mentions the null origin, which raises the question, what is the null origin? I decided to spoof the null origin to a whole bunch of sites and find out who trusts it. Turns out, quite a few people. Google's PDF reader trusts the null origin. So that's kind of nice. Additionally, a Bitcoin wallet trusts the null origin. Even better. And you can easily find a whole load more servers that have whitelisted this origin, either using Shodan or using Rapid7's sonar.http resource, which I highly recommend checking out if you aren't familiar with it. Cool. So, next question, pretty obviously, can we get the null origin? Who has the null origin? The accepted wisdom, if you look at Stack Overflow and the like, seems to be that local files, local HTML files on your own file system have the null origin. And I think that's probably why it gets whitelisted so often. So people think, okay, if someone has the null origin, they're clearly just a web developer rather than someone who's being hacked by a third party. Fair enough. And if that were the case, then whitelisting the null origin wouldn't be that serious. Fortunately for us, there's this fantastic HTML5 feature called the sandbox attribute for iframes. And the point of this is to allow sites to render untrusted content in an iframe, and it does that by putting the content of the iframe on a different origin from the parent site. You can probably see where this is going. What origin do you think it might be putting it in? Well, it's the null origin. So using these few lines of code, any website out there can get hold of the null origin. And what that meant was that I could read data from that Google PDF viewer, including users' account details, their Google Plus profile and user ID and so on. And also, I could grab hold of encrypted backups of users' Bitcoin wallets. And okay, they are encrypted, yes, but they're encrypted with users' passwords, which they've chosen on a site which at the time had no strength password meter or anything like that. And I've landed in a situation where I can launch an extremely fast offline GPU-assisted brute force attack against their wallets. And if I crack it, then great, I've got all their Bitcoins. So that's pretty nice. That issue was patched fairly fast too, actually. So, to answer the question, what is the null origin? Well, it's effectively the wildcard, but much less obvious. Because if someone looks at null, they're not going to think, ah, yes, you trust null, you trust everybody, right? But additionally, it's much more dangerous than the wildcard origin, because the exception where the wildcard doesn't work in conjunction with allow credentials doesn't apply to the null origin. So if you say I trust null with credentials or whitelist it for whatever reason, then you are completely destroying the security of your site. Additionally, there's one other catch, which is that null was, I honestly think, just a poor choice of words. Because there appear to be some applications out there where you're expected to, as part of the configuration process, specify a list of origins that you want to trust. And, you know, this is a programming language. If you happen to forget to specify any list of items, it just says, I trust null. And it's not trying to say, I trust every site out there. It's trying to say, you forgot to configure this list, you moron. But the effect is pretty bad. Okay, what else goes wrong? Well, let's take a look at a website that this is Google Finance. So this lets users specify lists of shares that they're interested in and how much they bought into those shares and that kind of stuff. And if I was a hypothetically very rich person, then this might be quite interesting information, quite valuable to the right people. So let's have a look at what they're doing with CORS. So this is the request to the server, and we can see straight off they aren't using any CORS headers that we can see. So what we're going to do is go, okay, that's standard, because they're probably dynamically generating them. So we're going to try an origin that we think that they probably trust. Hopefully some of you can actually read that. So I'm just saying I'm coming from google.com. And here we can see, yep, CORS is turned on, and they trust google.com. Okay, that's fine. So I can try the bypasses that I've already shown you, like appending content, but that doesn't work. And prepending content, which also doesn't work. And sending the null origin, which causes an internal server error, but doesn't actually do anything useful. But what we can see is that they do support arbitrary subdomains of google.com, right? And if we had cross-site scripting on a subdomain of google.com, that would be quite handy. But that's not what I'm here to show you. This is google.com. Getting cross-site scripting on one of their subdomains is not the easiest thing in the world. Something that's interesting is that they don't verify what protocol I'm using. So here, I'm saying I'm coming from an unencrypted arbitrary subdomain of google.com. I wonder if we can do anything with that. Okay, say that I'm in a position where I can intercept and modify the user's network traffic. So that might be because I'm in a coffee shop with them, or maybe I've done some BGP hijacking from my office. That's pretty fashionable at the moment. Or maybe I'm just the NSA sitting on every network, tampering with everything. Okay, if this target loads Google Finance directly, I can't view or tamper with that data because it's using HTTPS. It's all encrypted. But as soon as that user browses to anywhere over an unencrypted connection, because that's not encrypted, I can intercept it and send an arbitrary response. So in this case, they've tried to load CNN.com, and I'm redirecting them to http sub-evil.google.com. So the browser is going to automatically load this. And once again, this is an unencrypted connection. So I can intercept this request and send my own response. And I'm going to send them some malicious JavaScript using CORS. So this JavaScript is now going to send a request to Google Finance. And Google Finance is going to see this request coming from http evil.google.com. And as we've seen, they trust that origin. So they're going to go, yep, you've got access. And this sensitive share information that I want to get hold of has just been passed to a fake website that I made over HTTP, running my own JavaScript, which can then post that data off to me. Hopefully, Google aren't going to be too annoyed about me disclosing this. They are already aware of this issue and don't plan on fixing it in the short term. And from my point of view, that's fair enough because they're also not using strict transport security. So actually, there's a completely different way of achieving the same effect. But there are plenty of other websites that are using strict transport security where this behavior is a pretty big security hole. Just in case you're now thinking, great, I know exactly how to say I trust all of my subdomains securely, let me say just please don't do that. Because one of your subdomains probably does have cross-site scripting. Even some heavily audited applications like Bugzilla actually have cross-site scripting by design. Not to mention that some of the subdomains are probably hosted by third parties and you probably don't know that much about their security. And additionally, people can use things like hanging CNAMEs to just arbitrarily hijack subdomains. Finally, even if all of your sites are secure and you're not using any third parties and there aren't any hanging CNAMEs, some consumer ISPs have this fantastic feature where if a user tries to do a DNS lookup to access a site and that site doesn't exist, they man in the middle the connection and they spoof a response and create a search page, generally full of adverts, which is why they're doing it. You might have seen this. And some of these ISPs will even create these kind of fake search pages on subdomains of real websites. So there, what you've got is an ISP helpfully injecting a website you've got no control over into one of your subdomains. And somewhat unsurprisingly, these often have cross-site scripting vulnerabilities. You really, really can't trust all your subdomains. Okay, so far, I've focused entirely on exploiting sites that have allow credentials set to true. Exploiting sites when this is set to false is generally a lot more difficult. That's because when this header is set to false, users' credentials won't be sent, and that typically means that as an attacker, we might as well send that request directly from our own system rather than making the user's browser send it, and CORS is therefore not relevant. However, there are some cases where there's something special about the user's environment that we can exploit. The most obvious case is fairly well known, but I really have to mention it. And that's that if you say you allow access to all sites, using CORS even without credentials, that means attackers can proxy traffic through your web browser. And if you're like IntelliJ, which is a popular Java IDE, and you happen to bind the server to localhost, that means attackers can now send requests to that server. So someone recently found that that could be used with IntelliJ to steal users' private SSH keys, which is pretty cool. They also found, actually, that using some other issues, they could get remote code execution, and they got a $50,000 bounty for that, which is pretty nice. So this might be quite well known, but I absolutely have to mention it. Let's move on to something a little bit subtler. If you're reading the CORS specification, you'll notice a section titled Implementation Considerations. And these sections often have stuff that's incredibly useful for hackers. So what this section says is, if you're dynamically generating the allow origin header, you must specify the vary origin header. And what that header says is it means that caches won't incorrectly save responses and serve them up to the wrong user. You might be thinking, oh, okay, well, that's a static header, you know, that's really simple. How could anyone fail to do that? Well, I think the first people to fail this was the W3C, which led to this absolutely brilliant comment on their mailing list. So they wrote this specification, and someone wrote, I must say, it doesn't make me very confident that soon more sites will be supporting CORS, if not even the W3C manages to configure its server right. Fair point. It turns out, actually, plenty of sites do support CORS, but they just don't configure it right. So, what happens if you don't specify this header? Most of the time, things will just break. CORS will just mysteriously fail. However, sometimes things get a bit more interesting. If you've done a fair amount of web app pen testing, you might have encountered situations where you've got an unexploitable cross-site scripting vulnerability, like this one here. So here, the application is reflecting the X-user header insecurely, but as an attacker, there's no way for me to make my victim send that custom HTTP header across the main, so I can't directly exploit it. Now, thanks to the CORS policy that you can see, I can make the user send that request across the main. But this doesn't actually mean that I can exploit it yet. Because, great, I've sent this request, but because I'm using AJAX, the response from the server has merely been stored in a JavaScript variable rather than rendered in the web browser. So this malicious HTML and JavaScript that I've injected never actually gets executed in their browser. However, their browser is highly likely to cache this response for that URL, and because vary origin hasn't been specified, that means if I then redirect the whole web browser to that URL, their browser will serve them the cached version, which has the malicious content injected into it. And because that's exploiting the user's browser cache, that's a client-side cache, it's pretty reliable. It works almost every time. If the stars are aligned, then you might be able to get away with some server-side cache pointing. So, some servers reflect the content of the origin header without even validating that it's a valid origin. So they'll do things like reflect an origin header that contains the carriage return character. And Internet Explorer happens to view the carriage return character as a valid ending for a HTTP header. So what we've got here is a slightly weird type of HTTP header injection vulnerability. And once again, this is something that we can't exploit directly because there's no way for me to make your web browser send such a horribly malformed origin header. But I can manually craft that request, and if the response coming to me from the server happens to get stored in a server-side cache, and the vary origin header hasn't been specified, then this response may well be served to random other users. What this injection does is changes the char set to UTF-7, which is extremely helpful for triggering cross-site scripting vulnerabilities, and not much else as far as I can tell. This attack relies on server-side cache poisoning, and as such, the situations where you can exploit people can be quite limited. Like, you might be testing this server directly with no cache in between, but some other users may be accessing through a corporate caching proxy, which you could exploit. So it's pretty fiddly. There's one other situation that I should mention. Calling this a CORS misconfiguration is a little bit of a stretch, because it's kind of an intentional CORS misconfiguration. It's quite common to find classic HTTP header injection vulnerabilities where, for whatever reason, you can't inject into the response content. So you can't just inject malicious HTML. The only thing you can do is set HTTP headers. And CORS offers a brilliant way of exploiting this, because you can just say this content is open to everyone using CORS, and then other sites can get hold of that. So that doesn't rely on any caching whatsoever. Okay, what have we learned? Well, as a pen tester, the core to finding these issues is to look for them. Just bear in mind that you may well get no CORS related headers back from the server until you walk up with an origin that the server has whitelisted. So try the host name of the server, because servers tend to trust themselves, and also try null, and try any other server, any other origin that they may trust. If you like, you could do something like use a request rewrite rule to automatically inject the null origin onto all of your requests. Also, seek out APIs. I found that disproportionately APIs on websites have CORS turned on. Once you found it, well, you just need to audit it, just like it's an open redirect or something like that, but much more seriously. If you're a Burp Suite user, then you'll find an update waiting for you at the end of this presentation, which will do both of these steps for you. Finally, build an exploit. I've covered quite a few different exploits, but the core points to keep in mind are that you might not be able to use purely the CORS misconfiguration to exploit the site. You might need to use something like caching to build some kind of exploit chain to hit that target. How's the specification holding up? Well, the exception where the wildcard and the credentials headers don't work when combined seems to be a pretty good thing. It's protected some sites. So what I would suggest the specification authors do is apply that same exception to the null origin, because at the moment the null origin is quite a lot more dangerous than it should be. I would argue that the lack of support for partial wildcards, which means that you can't, with a hard-coded value, say I trust all of my subdomains, has forced a lot of people to do dynamic origin header generation, which they wouldn't have had to do otherwise, and has caused quite a few of the vulnerabilities that I've shown you today. So if the specification supported that, I think there would be less vulnerable servers over time. From the browser's point of view, I think multiple origins should be supported, because once again, that would reduce the number of people forced to dynamically generate the origin header. Also, something else that browsers could potentially do, I think without causing massive breakage on the current internet, is to block what I've called reverse mixed content. Basically, that attack that I showed on Google Finance. So where they could block access using CORS from a HTTP site to a HTTPS site. And that would help out the vast number of sites that forget to verify the protocol using CORS. Okay, if you're a developer, well, the key takeaway is if you can, just don't dynamically generate this header, hard code it. However, as we've seen, often you have no choice, and you just need to validate the origin with a huge amount of paranoia, basically. And don't forget to specify vary origin, and don't trust the null origin under any circumstances whatsoever. Please, it's the worst. I really don't know why the null origin exists. Okay, the slides have been published on our website, as has a fairly brief write-up of this talk, and there's another talk on CORS misconfigurations coming up this afternoon, and I've had a chat with the author, and it's going to involve some fairly different content, so it's probably still pretty interesting. The three key things to take away are that CORS misconfigurations are often critical, sometimes really quite subtle, and absolutely out there if you look for them. I'm going to take 5 minutes of questions now, and if you've got any questions after that, you can come and chat to me at the back or send me an email. Don't forget to follow me on Twitter. Thank you for listening. Cool, yeah. You were able to delete a profile using CORS, thanks to them enabling that method. I would think that sounds a lot like cross-site request forgery, so they should have cross-site request forgery tokens. Okay. You need to make sure that they only trust origins using CORS that are legit, that are not going to try to hack them by deleting users' profiles or such like. I think a lot of people just don't appreciate how powerful CORS is, how much damage it can do. If you can grab users' cross-site request forgery tokens using CORS, then you can do a hell of a lot of damage, basically. Okay. Go. Yep. Oh, sorry.
Have you seen companies accepting CORS misconfigurations as valid bugs if you have ever submitted any to a bug bounty program?
So all of the examples that I gave using real sites, all of the Bitcoin examples, I reported those to the sites and they were fixed. Yeah, I think the absolute key is just making a proof of concept that demonstrates that you can do something really bad. When you walk up and say, hey, I can use this to steal Bitcoins, they can't go, oh, that's not a vulnerability, that's a feature, right? Yeah.
So can you go back to the slide with the cache poisoning and HTTP header injection?
Sure. This one.
This one, yes.
Yeah.
So if you are injecting I think you had another one this one works as well. So if you're injecting a content type header, right?
Yeah.
But then the response actually generates a normal content type header, wouldn't it overwrite yours?
The browsers will tend to just pick one which they feel like. So it depends, basically.
So I have a question about the vary header versus the cache control header. Is there a reason using one or the other or both?
So if you specify vary, then what that says is when you get requests with, you can still cache this response, but you can only serve it to requests that have the same origin header that you cache this for. So if you say you can never cache this page, then that's just as secure, yeah. If you have like, yeah, then that would do the job, sure. That's more for, if you specify very origin, then that way you do support caching, but not dangerous caching, yeah. Anyone else? No, cool, thank you.
Thank you again to James.